All right, students, let's try one more equation problem that has a radical in it. In order to get started, I'd like to get rid of the radical sign. I notice that it is by itself on one side of the equation. So I can start this problem by getting rid of the square root. By squaring both sides. I'll square this side to get rid of the square root, but I must match that by squaring this side. Now something nice happens on the left-hand side. The square and the square root undo each other, leaving just the 6 minus x. But on the right-hand side, 4 minus x squared means 4 minus x times itself. That's a FOIL problem. Let's multiply this out. We'll multiply the firsts, 4 times 4, then the outers, 4 times negative x, then the inners, negative x times 4, and when I multiply the lasts, that's a negative times a negative is a positive. What a mess. Let's simplify. I'm going to put my x squared back up front. I'll combine my negative 4x's. Let's put the 16 at the end and copy the 6 minus x. Now it's quadratic, so I should set it equal to 0. My x squared is already positive, so I'll keep it where it's at. I need to get rid of negative 1x, so I'll add an x to both sides. Negative 8 and positive 1 is negative 7x. I need to get rid of this 6, so I'll subtract 6 from both sides. 16 minus 6, that's 10. Now we'll hope that this factors. Can we find two numbers that multiply to 10 and combine to negative 7? 10 could be 5 times 2, and if I make the 5 negative and the 2 negative, they'll combine to give me negative 7. Here come my two answers. What makes this 0 is 5. What makes this 0 is 2. It appears to have two answers, but I should be careful. We should plug these back in and make sure that they both work. If I plug in 5 for x, 6 minus 5 is 1, and the square root of 1 is 1. But if I plug the same 5 in there, 4 minus 5 is negative 1. Positive 1 does not equal negative 1. 5 does not actually work. Let's see if the 2 does. When I plug in 2, 6 minus 2 is 4, and the square root of 4 is 2. Plug the same 2 in there, and 4 minus 2 is 2. 2 works when I plug it in. That's really the only good answer to that equation. All right, go work some homework. That wraps up part 1. I'll see you later on today.